Hi, everyone. I'll be presenting our paper titled The State of Data Curation at NeurIPS. This work was done with PhD students and faculty at University of Toronto. The NeurIPS dataset and benchmarks track was created in 2021 so that enough datasets were being developed as ML applications were growing. This was important because datasets are often used outside the original scope they're created for, and this causes unanticipated ethical problems. Around the same time, research about data ethics proposed that bias in models can be reduced with better datasets and better documented datasets. Some of this research talked about ethical data curation and said that we should adopt concepts from fields like library and archival studies and digital curation to help improve documentation on datasets and data design decisions. The field of data curation stems from these fields and has deep-rooted and established methods on how to maintain large amounts of data and manage ethical concerns. But currently, there's a gap in recognition and uptake of data curation concepts in the ML research community. And so in our work, our goal was to show how data curation can help document and improve the standard of dataset development in NeurIPS. To this end, we explored three research questions. First, what constitutes a well-curated dataset? How feasible is the adoption of data curation for ML? And what is the state of data curation at NeurIPS specifically? To answer these questions, we took the following approach. We first made an evaluation framework composed of a rubric and toolkit by translating data curation principles and concepts for the ML dataset development context. To ensure that our framework could be applied feasibly, we examined the consistency with how it was applied for 30 datasets in the NeurIPS DNB track across 3 raters by measuring inter-rater reliability. We then applied the framework to another 30 datasets to evaluate the current practices of data curation and ML dataset development. So let's look at each of these 3 in turn. So here's our evaluation framework. It is primarily composed of a rubric. It has 18 elements across 5 groups, namely scope, ethicality and reflexivity, data pipeline, data quality, and data management. Each element in the rubric is evaluated on 2 levels, which are a minimum standard and a standard of excellence. We also developed additional resources to support the use of the rubric packaged together as a toolkit. This includes instructions about how to apply the rubric, guiding principles, recommendations, FAQ, and a glossary of key terms. To examine the consistency in application, we measured inter-rater reliability. And overall, we observed improvement in IRR per dataset across successive evaluation rounds. The values increased, moving from fair to excellent agreement among raters. Now, moving towards the current practices of data curation, we evaluated this by looking at evaluation scores by rubric category. So first, for good news, all 3 elements in the data pipeline category were 93% fulfilled for the minimum standard. These usually tend to be standard to report for publication, but documentation isn't always so great. We also find that documentation is rarely context-aware, meaning that no papers had a positionality statement and typically does not quantify environmental footprint. Both of these elements had 0% pass rates for the minimum standard. And overall, actually, when we look at all the scores, we found that documentation varies quite widely. And in fact, for the standard of excellence criteria, we found that documentation was often incomplete because even for those datasets with well-documented elements for the minimum standard, rigorous documentation was ultimately lacking. Lastly, our findings suggested no improvements occurred because there was a downward trend in documentation across years. So finally, we suggest strategies to improve data curation in ML for the areas that had low or no documentation. And I'll highlight just one for this presentation. To address requirements, we recommend dataset creators to write purpose statements and talk about how they translated the real-world problem they're addressing into a ML problem to promote transparency. We also recommend documenting the initial formulation of the problem versus how the dataset development was actually executed to help show the practicalities of doing data work. To conclude, we know that NeurIPS, with the creation of the DNB track, has sent a clear message that dataset quality is the foundation of continued progress in ML applications. And there is no better database of knowledge than data curation to aid in this venture. Our evaluation framework and its application to assess curation practices, therefore, provides a practical lens on how we can perform rigorous data curation in ML. In the next stages, we want to explore how researchers and practitioners can use this evaluation tool to better understand their curation needs and challenges. So we would like to hear from ML researchers who are interested in this approach. Please reach out if you are. Thank you.